rush to Mars is on.
We are by nature explorers, and so of course we'll go to Mars.
From the chief scientist at NASA,
We believe we'll have humans in the vicinity of Mars, hopefully in the early 2030s.
to the thousands who have signed up for a one-way trip.
I couldn't imagine a bigger adventure.
Billionaires are building private rockets and space stations.
Independent stations, lots of customers, lots of transportation going back and forth.
From Earth's darkest depths and haunting landscapes, scientists are looking for clues to Mars.
What a lot of people are searching for, the grand slam home run, would be to discover evidence of life.
If we can learn how to explore and to live on Mars, then there's no limit in space.
Go Delta.
People in future ages will look back at this particular time as the greatest moment in human history.
The passions are powerful and motivations many when the destination is Mars. For all of recorded history, that red light wandering the night sky has fueled human imagination. The Romans named it after their god of war. Others thought it was a distant civilization.
When the first telescopes were invented, it made Mars really interesting. When Galileo was looking through the telescopes and he could see the patterns on the surface. And then Percival Lowell in the States started using the best of the telescopes to look at Mars and wrote books about the fact that Mars was a dying civilization and convinced himself that he could see canals on Mars. And it fed the science fiction of the era.
Ladies and gentlemen, those strange beings who landed in the Jersey farmlands tonight are the vanguard of an invading army from the planet Mars.
Today, we are no longer satisfied with Martian fantasies. We want to go there.
Now, last month, we launched a new spacecraft that will send American astronauts to Mars, pushing out into the solar system, not just to visit, but to stay.
For one person, that vision is already a reality. Arissa Hines works on 2 planets.
Hi. Hello. How are you? Good. Go right ahead.
Thank you.
On Earth, she's an engineer at the Jet Propulsion Laboratory in Pasadena, California. Her other job is 250 million kilometers away.
When I talk to people about what we're doing, it reminds me of how amazing and awesome and unique this job is.
Arissa Hines has the coolest ride in the solar system.
Down at 90 meters per second at an altitude of 6.5 kilometers per second.
She's a member of NASA's Curiosity rover team.
We are in powered flight.
It's a robot explorer that arrived on Mars in 2012 to try to answer some very big questions.
Sky crane is started. Expecting final cut shortly.
Arissa Hines will remember this moment for the rest of her life.
Strong.
Touchdown confirmed. Proceed.
It was quite a night to be a part of. There was a sense of relief that it had actually worked, and then sort of this sense of awe that I had been a part of something that was now on a foreign planet.
It was an engineering milestone, landing the 1-ton Curiosity rover in the middle of a crater on Mars. And the images it transmitted became landmarks in the world's imagination.
There is something very home-like about Mars. Every turn around a corner, you've got new imagery that looks like something you might find in your backyard.
Arissa Hines is very much at home on Mars. It has become her backyard. Her job is to guide Curiosity meter by meter, rock by rock.
The first thing you do is look at the imagery that you have for the day, and so that's what I have up here. We have imagery that's from the mass cams that give us a sense as we get further out of what the geology of the terrain really looks like. And the cool thing is, as we have build-up commands for the rover and we simulate that, we can actually watch the rover on the path that we've developed. And as we're reviewing the terrain, we would do that using our cool three-dimensional glasses. Here's a rock that I would try to avoid. Is there a ridge there that I have to be careful if I'm going to drive through or over it? Is it a rock that's blocking my view? Once I have a good understanding of the terrain, then I am going to start planning my drive. And so here, what I want to do is try to get as far along the strategic route as I can, but using the details I have. My final heading I want to make sure is good for our telecommunications, so I have to make sure that my final heading is good.
To keep Curiosity on course, she spends a lot of time literally in the backyard, the laboratory's Mars yard, with the rover's double.
Curiosity has 50-centimeter diameter wheels, and so it's capable of going over a rock that's 50 centimeters tall, but that's sort of the limit of the capability that we would like to have it use, and only in situations where it didn't have any other choices.
There's good reason to worry about rocks. Curiosity's wheels have been getting dangerously punctured.
So part of what did so much damage to Curiosity's wheels were rocks that had been shaped by the wind, similar to this, wind and sand. And we refer to this on Earth as a ventifact. So you can find these within 100, 200 miles of Los Angeles and in other places in the world. And it turned out that there was a lot of this on Mars that we hadn't really anticipated. So we try to avoid really sharp, pointy things as well and go around them.
But despite these punctures, Curiosity relentlessly scours the surface about 30 meters a day. Then, on one of those days, Curiosity encountered some interesting rocks. It deployed its drill, and its instruments analyzed the sample. What Curiosity discovered made headlines around the world.
Noticias de última hora.
Curiosity has found traces of an ancient stream bed on Mars.
We have found a habitable environment that is so benign and supportive of life that probably if this water was around and you had been on the planet, you would have been able to drink it.
There's another kind of rock scientists hope that a rover will find on its journeys one day. The rock that proves there was life.
This is one piece of the puzzle, one very important piece of the puzzle, the rock I'm holding here.
Abigail Allwood has found these rocks on Earth. They're called stromatolites. They're a bit like coral, evidence of earlier organisms.
If we saw something like this on Mars with the rover, that would be a pretty amazing thing. That would be the holy smokes moment.
Curiosity's discoveries are helping scientists write the real history of the Red Planet.
You know, back around 3.5, 4 billion years ago, Mars wouldn't have looked that different from the early Earth. Large parts of the surface covered in water. Volcanoes on the land. Mars's atmosphere would have been denser than it is today. Same conditions to the early Earth, so we believe it's very likely that life would have evolved on Mars. Now, at some point, Mars lost its protective magnetic field. The solar wind, the stream of particles coming from the sun, started stripping Mars's atmosphere away. At that point, water was no longer stable on the surface. Mars became colder and colder. That water retreated underground, largely as ice. Now, did life go extinct? Or did life retreat underground? We don't know. We'd like to go find out.
You'd think a mine shaft deep under Sudbury, Ontario, is the last place you'd look for life on Mars.
As a kid, I certainly never imagined myself contributing to the exploration of Mars.
And yet here, Canadian scientist Barbara Sherwood Lawler finds herself descending 2 kilometers in depth and over 2 billion years in time. Because the rock in the Canadian Shield is as old as the rock on Mars.
There's nothing barren about this from the point of view of a geochemist or a microbe. Some of these rocks, when they undergo water-rock reaction, actually produce chemical energy that is the perfect food for microbial metabolisms.
2 miles underground, in some of the oldest rock on Earth, something is alive.
These are microbes, rock-eating microbes that draw their energy for life not from the sun's energy, not from photosynthesis, but from chemosynthesis. Reactions between the water and the rock produce energy that microbes can live in.
If life is to be found on Mars, it may just be these microbes. And the secret to finding them is to follow the water.
Well, these rocks not only have water flowing through them now, they retain the history of past water movement as well. And what you see here is literally a time capsule that shows us the pathway that water took in the past through a crack in the rock.
This rock was formed at the same time as Mars, and it may have a story to tell.
We're investigating that here because it's directly analogous to what might have happened in the past on Mars.
Barbara Sherwood Lawler has been looking for ancient water from the deepest and darkest mines on Earth. But she made her landmark discovery in the Canadian Shield, in a mine in Timmins, Ontario. It's in a plain-looking sample bottle in her University of Toronto laboratory, and it may contain an important clue in the search for life on Mars. This is what she found.
This is at the moment the world's oldest water. It's between 1 to 1.5 billion years old. We also know that there are components of this water that are even older yet. Some may even be as old as the rocks themselves, 2.7 billion years old. And in fact, one of the most exciting things we're investigating now is that there is life in this water.
These microscopic fluorescent stains are evidence that microbes are alive in this ancient water. She's testing to see what kind they might be. Perhaps they're like these microbes she found in South Africa. Whatever the microbe's age may be in the Canadian sample, it proves something can thrive in this salty, primordial, billion-year soup.
Deep, salty waters likely also occur deep within the Martian planet, and it provides a perfect target for us to begin to understand whether or not life might ever have arose on Mars, or in fact, might be there still.
While Barbara Sherwood Lawler searches the subterranean darkness of Earth, another scientist investigates a haunting landscape on the surface. Planetary geologist Bethany Ehlmann is studying Red Rock Canyon in California because it's eerily similar to Mars.
The biggest question is how warm and how wet was Mars in the past? So you could envision an environment that was anything like tropical Earth today, where there was rain and thunderstorms, water flowing down to form large rivers. Or you can imagine something like the dry valleys of Antarctica. And then there's the in-between, something like Iceland, where it's cold and wet. So a lot of times people ask, what's the grand slam home run for Mars science? I think, in many ways, and what a lot of people are searching for, the grand slam home run would be to discover evidence of a second planet in our solar system with life. All right, you ready?
But for her, this search runs deeper. It's not just about Mars, it's about Earth.
How did Mars evolve and change through time? And why did it go from a once water-rich world to the cold and dry planet that we see today? This tells us something very, very fundamental about how planets work and why some of them are able to sustain habitats for life throughout billions of years of history, like our own Earth. And then some of them dry up and end up cold like Mars. They turn into greenhouse hellhouses like Venus. Why is it that this happens? What drives this? So it's by exploring places like Mars that we really start to understand the controls over what makes places like Earth the special places that they are.
So Mars may hold the key to our past, and perhaps our destiny. And we're getting ever closer to setting foot on Martian soil. Everything about Mars is writ large. Olympus Mons, the largest extinct volcano in the solar system, 3 times the size of Everest. Valles Marineris, the largest canyon in the solar system and as wide as the United States. Orbiting cameras reveal stunning images. Wandering sand dunes, towering dust devils, titanic glaciers, and landscapes like abstract paintings. In the 21st century, the red planet beckons. And nations around the world are lining up to reach it. India has successfully launched its first Mars probe. The European Space Agency just sent this rocket, and soon after, the first private Mars rocket will be launched by SpaceX. By 2020, it's going to get crowded on Mars.
These are the models of China's Mars probe, which are...
China is sending an orbiter and lander. In Paris, at the headquarters of the European Space Agency, they are committed to landing and drilling.
Mars is something like a magnet for illusions, for visions, as well as the Moon was in the past.
Mars has also become a destination for national prestige.
This will be the first ever Arab Islamic mission to another planet.
The Emirates Mars mission will have a major impact and a legacy here in the UAE.
But no country is more advanced and determined than the United States.
We believe we'll have humans in the vicinity of Mars, hopefully in the early 2030s. So that probably means the first mission, just like with the first Apollo missions, we didn't go right and land on the surface. The first thing we did was orbit.
Pull it up a little and it'll suck it into the truss a bit. That'll probably be a lot better.
The first phase of the journey to Mars is what we call the Earth-reliant phase, and that really centers around the International Space Station.
Give me a minute, I'll work on that.
Every day, the astronauts from all around the world up on the space station are doing work to get us ready to send humans to Mars. Things like, how does the human body adapt to space?
Today, NASA is already preparing a new generation of astronauts for the challenges of deep space exploration. This is the giant training pool at the Johnson Space Center in Houston, Texas.
One of the coolest things about this job is that we're doing something different every day. And one day we're flying an airplane. The next day we're in the spacesuit doing a training run in the neutral buoyancy lab.
Before joining NASA's astronaut corps, Jessica Meir was already a distinguished physiologist, studying animals that thrive in extreme environments.
I'll never forget the first time that I was diving in the Antarctic, and you go through this ice hole and you're not really sure what to expect. There's no sign of life other than the other humans around you. And then you plunge beneath the surface, and that's where all of the color and all of the life is. And it's simply astounding.
She's traded in her dive suit for a spacesuit, and she brings her experience to the astronauts who will make the epic journey.
Now I'll be a subject for those experiments. So after organizing the experiments, then experimenting upon all these other animals, finally I'm going to become the guinea pig, so I guess it's my turn. We think about the long journey to Mars, the fact that it'll take about 6 to 9 months with today's technology. There are some main areas that we need to be prepared for. And I think one of the principal ones is that of radiation, understanding how to protect humans from the radiation dose that they would receive in getting to Mars.
NASA engineers are already building Orion, the space capsule that will get them there.
We need to make sure that humans can be protected as much as possible from space radiation, those streams of particles coming from the sun. Now, it turns out those particles, while they're moving extremely rapidly, they're still moving slowly enough that we can fairly effectively shield against them, especially with extra layers of metal. And it turns out water is a potentially effective shielding material. So we sort of know how to protect the astronauts, but we've also been looking at what's the duration astronauts would spend in deep space, what's the likely dose they would get, and how much of a risk is that?
How will they live? The round-trip journey, including the time on Mars itself, could take as long as 3 years. And NASA is already experimenting at the Houston Space Center with a project called HERA.
HERA stands for Human Exploration Research Analog. So that's a long name for a habitat that we use to imitate a spacecraft that might be doing a long-duration mission.
Lisa Spence is in charge of studying how 4 astronauts can live in this module without killing each other.
You're really looking at a time period of several years for crew members to be only interacting directly with each other. And so we want to make sure that we understand how we can best take care of all of the physiological as well as psychological aspects that our crew members are going to go through on those long-duration exploration missions.
Giving them space is vital. The first floor is the work area, and then the elevator to the second floor takes you to the living area. Up above are 4 sleeping modules. It's tight, but there are condos in New York that are smaller. On a 3-year mission, what are astronauts going to eat? NASA is already growing salads in space. Now it's testing a timeless classic.
Potatoes are one of the most studied crops by NASA, and they turned out to be, and they are, an excellent crop. They're nutritious, they're very productive, so they have a lot of positive attributes.
On Mars, the astronauts will need a way to get around the planet's surface. And that's the Space Exploration Vehicle. It's striking the amount of planning, design, and construction that's already going on to get us onto Mars.
The strategy on Mars will be to take 2 of these vehicles and explore with 2 crew members each in 2 vehicles. One of these will sustain 4 crew members, so if you do have one vehicle break down, you transfer into the other and then you go directly back to your base. The Space Exploration Vehicle has 2 suits, and you access them from the back of the vehicle. You open this up, and then you climb into the suit by doing a chin-up from the chin-up bar, and you put your feet in first, and then when you close your life support system and the door to the cabin, you do pressure checks to know that it's okay to leave the vehicle.
The primary reason for these external suits is to keep the Mars dirt out.
And that's from working with the guys on Apollo, all of the crew members that actually walked on the moon, and that they had trouble with lunar dirt inside the cabin.
I am working on the suits that we will one day see on Mars, hopefully in the 2030 time frames, but it will be a suit very much like the one standing here next to me. A spacesuit in general is already a complex problem because a spacesuit, you can think of it as a personal spacecraft for one. It has to do everything to keep a person alive and able to work in a very extreme environment for long periods of time. Mars specifically also poses some unique problems. We have to think about how our materials are going to hold up to the radiation environment on Mars for long periods of time. We're used to, with the astronauts in the International Space Station, being close and being able to talk to mission control whenever they have an issue. But for Mars, with the time delay in communications, the astronauts have to be able to do things themselves and they have to be self-sufficient when they're using the suit. So there's a lot of focus on making sure that they can use the spacesuits without a lot of assistance or a lot of help from flight controllers on the ground.
But they'll need oxygen, not just to breathe, but to get back. There's almost no oxygen on Mars. This is the high security laboratory in California, where they're designing the most remarkable Mars project of all.
The big problem we have going to Mars with humans that requires oxygen is burning the fuel to take the crew home. It's something we don't tend to think about on Earth. When we burn a gallon of gas in our car, we burn tremendous amounts of oxygen as well, but we get that for free. In space, on Mars, we have to bring it with us.
At the Jet Propulsion Laboratory in Pasadena, Michael Hecht is designing a way to turn Mars' toxic atmosphere into oxygen, mechanically.
That machine is MOXIE. That's what we're building and sending to Mars in 2020 as a demonstrator to show that we have the means in a compact package to fly a little tree to Mars in a compact package that'll breathe in carbon dioxide and breathe out oxygen. What you see behind me is a laboratory version of what we hope to send to Mars. All we have to do is take all that stuff back there and put it in a box this big, and then we're ready to go. So we need a plant at least 100 times this size, and over the course of a year, it will gradually fill up with liquid oxygen that will be ready for a human crew to fly back to orbit and rendezvous with a vehicle that will take them home.
But even if all these projects work, there's one great hurdle: the length of the journey. Chris Hadfield commanded the International Space Station and spent 5 months in space. Almost as long as a one-way journey to Mars. He says we have to wait for much faster spacecraft.
What if someone gets appendicitis? What if we've designed something wrong? What if our power system fails, if the radiation's too high, if our food starts spoiling, if all sorts of ifs. Toilet stops working, oxygen system stops purifying. We are absolutely beholden to those things, whereas if you could get to Mars in a few minutes, they wouldn't matter.
5, 4.
But despite these obstacles, NASA is pressing on. In Utah, another test and an almost satanic sight. NASA is building the most powerful rocket engine on Earth. One day, it will launch a crew into deep space. But why are we going? For NASA, it's science and exploration. But there are other forces feeding Mars fever.
You know, it's a good story. We're going to go put people on Mars. We're going to become a multi-planet species. But at the same time, the money we spend on civilian space helps prop up this very powerful aerospace industry, which has a huge significance to the country in terms of national security. So aerospace, these big companies, they don't just send up civilian rockets. They also send up military satellites. They build missiles.
And they also build military spacecraft that fly secret missions we don't hear much about. Like these robotic space shuttles that the US Air Force has been sending up for years. China and Russia also have their own secret objectives in space.
If you simply look at telescopes in orbit around the Earth, most of them look down. They don't look out at the rest of the universe.
Science may have led the way to the stars, but today, space is the new frontier for private enterprise. From space tourism to Mars rockets, billions of dollars in contracts are at stake in the commercialization of space.
Spaceflight has always been commercial. It's companies for profit building hardware. Richard Branson and Virgin Galactic, they signed big contracts with the government, and then they also have their other profitable ventures that all feed together in order to be able to do something new.
It's led to the rise of the space entrepreneurs.
What is going to lift off from Launchpad 36? Well, I want to give you
Amazon billionaire Jeff Bezos has started his own rocket business.
the new orbital vehicle.
And SpaceX billionaire Elon Musk has already wowed the world with his reusable rocket and his visions of Mars.
SpaceX, or some combination of companies and governments, need to make progress in the direction of making life multiplanetary, of establishing a base on another planet, on Mars being the only realistic option, and then building that base up until we're a true multi-planet species.
But in Las Vegas, Nevada, there's one billionaire who sees space from a completely different angle.
We are a general contracting company, because that's my background. And so I'm used to building an awful lot of different kinds of structures and buildings.
On Earth, Robert Bigelow has made billions building budget hotel chains. And now he wants to build big budget accommodations in outer space. His inflatable modules travel into space like empty balloons. When hooked up, they inflate into very cost-effective habitats.
We look at Earth's orbit as an income stream, which is very important. To have a number of independent stations, lots of customers, lots of transportation going back and forth and driving the cost down further and further for everybody.
The customers he's thinking of are multinational corporations like Disney, or countries seeking prestige. And this isn't an eccentric fantasy. Bigelow has already launched 2 test habitats into orbit. And this third one is getting ready to go to the International Space Station. Eventually, he wants to have a community of them on the moon.
To us, that could be a really important demonstration of something that might be perhaps applicable to Mars.
A couple of years ago, Robert Bigelow came to town and talked about property rights on the moon. The man wants to own big chunks of the moon.
Washington Post reporter Joel Achenbach was initially skeptical, but as he learned more about Bigelow's approach, his opinion has changed.
You could imagine that before we go to Mars, you could have this orbiting habitat, built by Bigelow or some other contractor around the moon, and that you could have long duration missions with astronauts in lunar orbit that would give you a little bit of an analog to a long duration mission to Mars. And I think now we're talking something that feels plausible to me and doable.
Spring 2016, at Cape Canaveral, a milestone in the privatization of space. It looks like a classic NASA launch, but today's mission is all about private enterprise. The Falcon 9 rocket is built by Elon Musk's SpaceX, and part of the payload is Robert Bigelow's inflatable habitat. The Bigelow habitat successfully inflates on the International Space Station, where it will be tested for the next 2 years. This may be how we live on Mars.
We need to move out and to have populations in other places, absolutely.
And Robert Bigelow hopes that his inflatable habitat will be part of that brave new world.
Imagine a colony under some kind of its own government What would their philosophies be? What would their religions be? It would be fascinating to find out.
Today, scientists know that Mars was once much more like Earth, a planet that could have hosted life. But then the oceans vanished. Finding out why is one of the great challenges facing scientists like Victoria Hipkin of the Canadian Space Agency.
A very strange feature of Mars is something called the dichotomy, where the southern part of Mars appears very ancient, it's very heavily cratered, and the northern part of Mars seems to be very smooth and quite recent, with a ridge in between them. So one theory is that there was a catastrophic impact in the north of the planet that actually blew off a lot of the Mars atmosphere and represented where there'd been an ancient ocean at some point, but also potentially contributed to the loss of water from the planet in this early period of Mars history.
A violent past, but the allure of a resurgent future. Mars is capturing the imagination of a new generation. As we see cascades of vivid images and discover that hidden water remains, Mars becomes tomorrow's dream.
I would go to Mars. I would love to do an experiment. Maybe I can live there a few months. That'd be really cool.
They found water underground. They found a lot of the underground oceans more. So when you go into that, you think, oh, there's more sense that you could live with water. That's what humans want, water.
We always want to go for the next frontier, right? We want to explore the unexplored. And Mars is the next closest thing.
Mars captures all of our imagination. When you see one of our beautiful panoramas returned by the Curiosity rover, it has a familiarity, a comfort about it that I think makes people say, that's a place where maybe someday humans can live.
That is what makes us so intriguing as a species, is this curiosity that pushes us to do things, but also that drive to go beyond, to outdo ourselves, to outperform ourselves.
Then there are those who have a more fantastic motive for going to Mars.
Current, future, and then long-distance future of Mars all wrapped up in one beautiful flag.
They plan to colonize it. Here, hundreds of scientists, engineers, writers, and amateurs from around the world gather in Washington for the annual conference of the Mars Society. Baz Lansdorp made headlines worldwide by asking for volunteers to go to Mars.
And we want to send humans to Mars in 2027 on a mission of permanent settlement, one way.
Mars One will establish human settlement on Mars.
His Mars One project wants to send volunteers to Mars and turn it into a TV show.
The value of everything we do, so the media exposure value of everything we do between today and 1 year after the first human landing is about $36 billion.
He's already received 200,000 applications to go there. Here are some of the finalists.
I couldn't imagine a bigger adventure than colonizing another planet, in this case Mars.
Going to Mars will be a great sacrifice, also because I really love this planet.
I would be doing something for science and for mankind.
It is my great pleasure to introduce one of my biggest heroes, Dr. Robert Zubrin, President and founder of the Mars Society.
But the real moving force behind the worldwide Mars Society is Robert Zubrin, who has done more than anyone to lobby for a mission to Mars.
We need to, once again, astound the world with what free men can do. And that means we need to accept the challenge of Mars. Thank you.
Zubrin is an astrophysicist who has championed the vision of human colonies on Mars for 30 years.
People in future ages living on thousands of planets orbiting stars in this region of the galaxy will look back at this particular time as the greatest moment in human history. This is the time when we left the cradle.
He not only wants to colonize it, he wants to transform it.
We will not just bring life to Mars, we're going to bring Mars to life. The first step is global warming. We clearly know how to achieve global warming, and we need to put this knowledge to use in a more productive sphere. And if we were to be producing that stuff on Mars in factories, we could warm Mars by 10 degrees centigrade in 50 years. That warming would force massive amounts of carbon dioxide to outgas, greatly thickening the atmosphere and adding its greenhouse potential to the mix. Then the water, which is currently frozen into the Martian soil, would start to melt out. And on that Mars, a warmer, wet Mars with thick CO2 atmosphere, we could very rapidly green the planet. And the plants could then produce oxygen, and eventually, with active human help, in about 1,000 years, produce enough oxygen that humans and other higher animals could breathe it on the outside.
But for others, the vision of Mars is rooted in a fear that Earth may be doomed by climate change, war, an asteroid impact, or overpopulation. And when one scientist spoke up, everyone listened.
I see great dangers for the human race. It will be difficult enough to avoid disaster in the next 100 years, let alone the next 1,000 or million. Our only chance of long-term survival is not to remain inward-looking on planet Earth, but to spread out into space.
Is Mars going to become our fallback planet? In just one generation, space telescopes have transformed our view of the universe. Chicago, just west of Lincoln Park. In the evenings, Lucy Ann Walkovich spends her spare time singing in her punk rock band. But during the day, she's a rising star in the field of astronomy.
A lot of people in my field become astronomers because they have access to a nice dark night sky or a small telescope or something like that. I grew up in New York City. I actually came to astronomy because I really liked chemistry and physics in high school.
She got the job of her dreams when she was hired to hunt for planets in a mission that made galactic history.
NASA's Kepler mission was a space telescope that was launched in 2009 to look for planets around other stars. And not just to find all the planets in the galaxy or even the closest ones to Earth, but rather to answer a very specific question. How common are planets the size of Earth around stars like our sun? Since 2009, just in the prime part of its mission, Kepler discovered almost 2,000 other worlds. Those 2,000 planets actually tell us that planets around other stars are very, very common. And that means that within just our Milky Way galaxy, there are likely to be billions of planets around other stars.
Billions of planets means possibly millions of habitable ones. And one of them is our next-door neighbor.
So what is it that humans can accomplish in space that is unique, something that is truly worthy of the cost and risks of human spaceflight?
Robert Zubrin believes we have an appointment with destiny.
Is humans to Mars. If we can go to Mars in our time, then within a century, there will be new branches of human civilization on Mars with new customs, new laws, new dialects, new literature, certainly a history of invention dealing with the novel conditions of their frontier. And that is a grand beginning to human history. And we can make that happen. And if you can make something grand happen, then you should.
That's the romantic vision. There are others like astronaut Chris Hadfield, who agree with Stephen Hawking that we'll have to leave the Earth one day just to survive as a species.
There have been several times in human history where we have been in one location and something changed about that location and it drove us into extinction in that area. One of the reasons to explore the rest of the universe is to give us options if life on Earth is threatened. Things like enormous sustained volcanic eruptions that poison the atmosphere, or an impact event from an asteroid or a comet that hits the world and envelops the whole world in flame. And just like a small community living on the edge of a drying up lake, we either have the choice of staying and dying or going somewhere else.
Of course, on a long-term perspective, I agree with Hawking, who is saying that we have to leave the Earth. On a long-term perspective, yes. On a short-term perspective, it's exactly the opposite.
First, many argue, we have to do everything in order to keep Earth habitable.
Sure, there could be a natural disaster here on Earth that would create some sort of crisis situation. But in general, I think the idea of Mars as a backup planet is a tempting yet dangerous one. As a species, human beings love to be able to put off hard decisions. The idea that we might relocate to a different world allows us a little bit of relief from some of the things that are happening here on Earth. I think the implication that we will gleefully leave this world and go inhabit Mars and that it will be just as good is a little like the captain of the Titanic telling you that the real fun is happening later on the lifeboats.
And to me, the more we talk about a backup planet, the more we're not focused on the most important planet in our solar system, which is the Earth.
And the closest danger, of course, for us are the humans. Humans on Earth are the biggest danger we have, and therefore we have to make sure that we survive in order to escape.
We're witnessing a very slow-motion climate catastrophe. It's interesting that we're willing to talk about terraforming or changing the entire habitability of another world when we're already accidentally changing the habitability of this world and we don't actually know how to stop.
I think it would be exciting to go to Mars. I think it would be really interesting scientifically, but I think here on Earth, we'll make our stand as a species. I think it is, we owe it to ourselves as Earthlings who are at our cellular level, our metabolic level, the way we are designed. We are of this planet, and we are connected to all other life on this planet, and our future needs to be here on Earth.
And we're thinking again, now we're gonna go and colonize and settle somewhere else. Maybe we should spend more time taking care of our planet before we think that we need a backup planet.
Any kind of scenario that views Mars as a fallback position, I have a sort of an ethical objection to that, because I would say, so what happens to all the other species on Earth? You know, what happens to the whales? What happens to, you know, the beetles, the insects, all the things that make this rich biosphere that we live in so astonishing and amazing? The big technological, ethical, moral challenge for the human species is to save this planet.
I'm probably a purist, and I think of Mars more as like a national park, except it's an international park, a solar system park, and I think we should probably leave Mars well enough alone.
One of the most inspiring images to me that have come from Mars has actually been a picture looking back towards Earth, with Earth as a tiny dot in the night sky. And even from our nearest planet, one would never expect that that tiny dot was full of life. People at school today, you know, going to work, to their offices, driving around the planet. Mars, it seems totally insignificant, this pale blue dot. Mars is a reminder of how precious our own planet is.
Today, Mars may be exclusively populated by robots like Curiosity, but one day soon, the tire tracks will give way to footprints. Whether we stay depends if Mars is today's delusion or tomorrow's destiny.